All right, here we are for ionic compounds. And first we'll start with some background information. It is helpful if you have your periodic table out while we do this. So go ahead, pause the video, pull that out. And first thing we're going to do is outline this periodic table. And what I'm doing is looking at the pattern of how many valence electrons these have. We know the noble gases have 8 valence electrons, and so that they have a full outer shell, and therefore they do not react. Now let's look at a Bohr model of magnesium. So magnesium is located right here. Magnesium has an atomic number of 12, so it has 12 protons in the nucleus. And then we're going to say this is magnesium isotope 24, so the mass is 24. 24 minus 12 leaves 12 neutrons, because protons and neutrons are the items with mass that contribute significantly to the mass. Then magnesium, a neutral atom of magnesium, has 12 electrons to balance out the 12 positives. 12 negatives, 12 positives would be neutral. We know on the first shell, or the first energy level, it can only hold 2 electrons. And then this next one, 8. So 2 plus 8 is 10. We said 12. It's going to take another shell to hold 2 more. 1, 2. So looking at this, those are the valence electrons, and it does match our pattern here that since it's in this column, its outermost shell would have 2. Now when you're thinking what ion will form, we got to think about how this is going to interact with other ions out there. Magnesium's goal is to have a full outermost shell. So it could either try to find somebody or multiple elements to bond with to try to gain 6 electrons. Because if it gains 6, this outermost shell is full. Or it could find an ion or ions to give these 2 away, to transfer these away, so that it would go down to a full shell. So if these disappear, 2 of them disappear. So we think, is it easier to try to get 6 and fill it, or is it easier to transfer 2 away? Well, doing 2 things sounds easier than doing 6 things. So it's going to get rid of these 2 electrons or transfer them away. So we'll make ourselves a note. So it will give away the 2 valence electrons to go down to a full shell on the second energy level. So our next thought is, if it gets rid of 2 electrons, what is the overall charge? Well, it still has 12 protons. But if it gets rid of 2 electrons, it had 12, it gets rid of 2, it's got 10 electrons. The overall charge would be -2. So now we know magnesium ion has a charge of, oh, why did I say -2? I'm so sorry. You're probably sitting there going, that's wrong. Yeah, it is. 12 positive, 10 negative. That's more positives. That's +2. So magnesium ion has a charge of +2. And when I write that, I'm going to put the atomic symbol in +2. From this, we can look at the periodic table and see, since all of these have 2 electrons on their outermost shell, they're going to follow that pattern, and they will form a +2 ion. Next one I'd like to look at, so that will be example 1. Example 2. And let's just go with fluorine. So we're going to do the Bohr model. Fluorine has atomic number 9. I'll give 10 neutrons and 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it almost has a full shell, but it wants one more valence electron to achieve a full outer shell, which we call octet. Oct meaning 8. 1, 2, 3, 4, 5, 6, 7. So if it gets one more, it would have 8. If it gets one more, if it gets one more electron, that means we have 9 protons and a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So the overall charge is -1, which means fluoride, I'll explain that in a second, has a charge of -1. I'm just going to do the symbol. Notice how when it was magnesium, I said magnesium ion. But when it's fluorine, I didn't say fluorine ion, I said fluoride. Those are what we call nomenclature rules, and we'll be learning more of that. Nomenclature is just a fancy word for naming. Some other terms we need: cations. That's any ion with a positive charge. And when we are doing the nomenclature or the naming, you use element name plus the word ion. So this had a positive charge. That's why I used the element name and put the word ion, magnesium ion. Now down here, this is an anion. Anions are any ion with a negative. And when you do naming, we use the suffix "ide." So instead of fluorine, we have fluoride. If it has a charge. I've been using this word a lot. I assume you know what it is. And I'm using the word ion. So if you want to write it off to the side, ion, element with a charge. So if it's positive or negative, it's still an ion. If it's positive, it's a cation. And if it's negative, it's an anion. Well, let's go back here. This had 7 valence electrons, and we figured out it will form an ion with a charge of -1. So anything here in the 7 is going to form a charge of -1. So if you did an example from all of these, we would see how the pattern works. And I hope that's what you're getting from this. So we can memorize this pattern once we understand the background of why to help us work a little bit quicker. Again, we're going to my favorite periodic table outline. I guess that should have been up higher, but for this pattern, it's okay. Let's put in the 2 numbers that we did the examples with the Bohr models. So we did magnesium, and we said anything in that column is going to want to give away 2 on the outer shell to go down to a full shell, so +2. Then we did right here fluorine, and we said it wanted to gain an electron, so it would be form a -1 charge. Our noble gases already have an 8 on the outermost shell. No charge. They will not form an ion. Over here, our alkali metals have 1 on the outermost shell, 1 valence electron. They would like to get rid of it and go down to a full shell. If you get rid of a negative, you become a positive. Boron and aluminum here, these are transition metals. We don't worry about those right now. But boron and aluminum have 3 on its outermost shell and would like to get rid of those. So it'd be +3. You get rid of 3 negatives, you have a positive charge. These are interesting. They have 4 on their outer shell. Most notably, that is carbon. And depending on what they're surrounded by, they'll behave differently. Sometimes they'll gain 4, and sometimes they'll get rid of 4. So I'm just going to skip that for now. These have 5 valence electrons on their outermost shell. They need 3 more to get to 8. When you add 3 negatives, your overall charge is -3. And if you really want to write something in here, you could say it forms +4 or -4. Once you understand why this occurs, this is great to have memorized. +1, +2, skip the middle, +3. -3, -2, -1, nothing. So we can quickly think name and write the symbol for the following. Ions that the element will form. All right, number 1, we'll do sulfur. So sulfur, we figure out where it is on the periodic table. It's right here. So it will form S-2. And it's named then because it's negative, it'd be sulfide. What about sodium? So sodium is located over here. It will form a +1 ion, and that is sodium ion. What ion will boron form? Boron is located here. Formula B +3. And it is positive, so boron ion. Our non-metals are what form the negatives. And that's a good note to add on here. Metals form cations, which are positive. Non-metals form anions, which are negative. Let's go through. The more you use these, the more the anion nomenclature becomes clear. So instead of saying nitrogen, if it has a charge, it's nitride. Oxygen, oxide. Fluorine, fluoride. Phosphorus, phosphide. Sulfur, sulfide. Chlorine, chloride. Selenium, selenide. Bromine, bromide. Iodine, iodide. Now that we have the backbone for ions, we can move on to ionic compounds. Let's go back to our Bohr models of magnesium. We're going to draw them again. And fluorine. So we know that it wants to give away 2, it wants to gain 1. If these 2 make a compound together, we can see what's going to happen is that's going to go there. But then you think, what about that one? Well, this fluorine doesn't want it. So when you have a compound of magnesium fluoride, it's going to take another one of these to accept magnesium's additional valence electron. Okay. So that's 1 magnesium and 2 fluorine. And as we name it, it's magnesium fluoride. It is considered ionic because it is made of ions. An ionic bond forms because of the transfer of electrons. What direction does it transfer? From the cation to the anion. From the metal to the non-metal. That's the way the electron transfers there.